Light from a helium neon laser passes through a narrow slit and is incident on a screen 5.2 meters from the slit. The graph to the right shows the variation with distance x along the screen of intensity I of the light on the screen. The wavelength of the laser is 632.8 nanometers. Determine the width of the slit. Okay. So here is this same diagram in terms of angle. Here it is on our screen here. And so we know in millimeters that there is a minimum right there. It's like a little careful graph reading. It's actually a little bit to the left of that, okay? Okay, so every little dash here, if this is 5 millimeters, that's 0.5 because there's 10 little divisions here. So we are basically 6.5 divisions times 0.5 millimeters per division. Let's figure that out. This is what I do too, and I read graphs because I'm so bad at this, right? And the IB will give you things where like every division is 0.04 or something like that. And so I just count the divisions. This is definitely 6.5 divisions is where that minimum occurs, right? And every division is a tenth of 5, so it's 0.5, right? So 6.5 times 0.5 gives us 3.25, okay? So x is 3.25 millimeters is how far apart this thing is, right? Okay, and the screen is 5.2 meters from that slit, right? So that means that our angle in radians is equal to just S over L, right? So that's going to be 3.25 times 10 to the minus third meters divided by, and it's 5.2 meters to the screen. Okay, so 3.25 times 10 to the minus third divided by 5.2, dyslexics beware. This is an angle of, and this is going to be radians because I didn't do anything else. So this is 6.25 times 10 to the minus fourth, right? Okay. That represents in angle lambda over d, right? Okay. So what do we do? Oh, the width of the slit. Okay, so we're solving for d. So literally we can just say that theta is equal to lambda over d as well, right? Where d is the width of the slit, right? So we're going to go 6.25 times 10 to the minus fourth radians. You can only do this in radians, okay, is equal to the wavelength, which is 632.8 times 10 to the minus ninth divided by d, okay? D is what we're solving for, so let's solve for D. Okay, so how do we do that? I guess we go this divided by that guy. So 632.8 times 10 to the minus ninth divided by the answer that I just got. And I get that that slit, that D, is equal to 0.00101248 meters, or 1.01 millimeters. So that's pretty simple, right? Okay. Then it says what two changes? Oh, there's two B's. Okay, let's make it a B and a C. What two changes would happen with the pattern if we were to increase the width of the thing? Okay. Notice that this angle here is lambda over d. So if d gets bigger, the angle gets smaller. So this thing's going to get narrower. Okay. And then it's just a wider slit, so more light gets through, so it'll be brighter. So this is going to go up, and this is going to be like, here we go. Okay, sorry. Okay, what would happen to the pattern if we were to increase the wavelength of light? Okay, so if you increase the wavelength, let's look at this. Okay, this is the angular separation here. If lambda gets bigger, then this thing gets bigger. Right? I don't know what happens to the intensity, okay, but it just spreads this whole thing out. So if you could imagine if this is like an auto shape, if you could picture this, right, and you click on it, you get that little handle on this side. If you just stretch the X but don't change the Y, that's what this would look like. It would just be wider, okay, because lambda would be bigger.